Okay, the inverse Laplace transform of S over S squared plus pi squared. Well, you have the Laplace transform of cosine of omega t and, S over S squared plus omega squared. I probably ought to walk over to the table and check that, but I'm going to go on faith for a minute. Okay, and sine of omega t has Laplace transform omega over S squared plus omega squared. Now, we've very recently done these integrals, and we see where the omega comes from here and where the S comes from here. And those integrals are straightforward, first-year calculus integrals, not difficult. Not the easiest possible, but not the most difficult possible either. There's no trig substitution. You don't have to use partial fractions. You don't have to do anything, just plain old integration by parts. Okay, anyhow, we get those, okay? So let's just talk for a moment about how we get this. Well, this one is really obvious, okay? S over S squared plus pi squared equals S over S squared plus omega squared if omega equals pi. So if we let omega equal pi, which it does, then this matches what? Cosine of pi t. So the inverse transform of S over S squared plus pi squared is the cosine of pi t. Nothing to it. Now, we have the A factor here, so we're not done, but figuring out the A is just an exercise in working out the partial fractions, which we haven't touched yet. Okay? And then, and this is similar to inverse transforms we've seen in previous classes. 1 over S squared plus pi squared is like omega over S squared plus omega squared for omega equals pi, because the denominator wouldn't match if it didn't. But you don't have that omega up in the numerator, okay? Well, you're missing the omega in the numerator. If you got a 1 up here, then this is like 1 over omega times this, okay? So this is 1 over omega times omega over S squared plus omega squared for omega equal to pi. And the inverse transform of this, I have to spill over down here a little bit, but the inverse transform of 1 over omega times omega over S squared plus omega squared is, omega is just a constant. In this case it's pi, but I haven't written it that way. It's 1 over omega times the inverse transform of omega over S squared plus omega squared. And of course the inverse transform of this is sine of omega t. So this equals this, and the inverse transform of this then equals 1 over omega sine omega t. So, inverse transform, getting kind of small here, but you should have good resolution, of 1 over, you've got good resolution, I don't. That's 1 over S squared plus pi squared. This thing is 1 over pi times the sine of pi t. Okay, now most of that should be legible. The only thing you can't really see here, this is s squared plus pi squared in the denominator here. Just like it was up here, but in a different expression. So you see where I get the sine of pi t over pi. And I multiply that by b, and here I've got this term. Okay? Well, both of those are pretty straightforward. Both of these involve a shift function, so we want to stop and talk about that.